In example 4, we're told Sherry plans to enclose her rectangular garden with a picket fence. She purchased 38 feet of fencing to enclose the garden, which is 5 feet longer than it is wide. Find the dimensions of the garden. Alright, looking at this, let's draw it real quick. That's a rectangle, I promise. And something like a rectangle. We're told that the width, it's 5 feet longer than it is wide. So if I have W and L, I should be able to determine some relationship between W and L. It's 5 feet longer than it is wide. So I think that's saying that L equals W plus 5. In this example, I'm not going to explicitly write down the meanings of L and W, as I think L standing for length and W standing for width is pretty clear, but that may be helpful if you want to do that. Alright, now she purchased 38 feet of fencing. Now the fencing is going to go all the way around the outside. All around the outside. Well, if I look at this picture looks like it's got 2 L's and 2 W's. So the total length of the outside here is 2L plus 2W. That's the perimeter. It's the formula for the perimeter. Equals 38 feet. Again, you may notice I already have this equation solved for solved for L. So since it's already in that format, I'm going to substitute L into the second equation and use substitution to solve this. I'll have 2 times W plus 5 plus 2W equals 38. Working this through, 2W plus 10 plus 2W equals 38. Combining the terms on the left, I'll have 4W plus 10 equals 38. Subtracting the 10 from both sides, I'll have 4W equals 28, or I need a little more room here. Dividing both sides by 4, W should equal 7. So L then would be W plus 5, that is 7 plus 5, or 12. And rereading the problem real quickly, I should see the units are feet in both cases. And it looks like L is 5 feet more than W. To reiterate here, when I'm starting off here, to help me make sense of the question, I want to draw a picture when I can. And that really does help. I get my nice system of equations, and I could use substitution, or if I wanted to, I could set this up to use elimination. Though substitution seemed like the natural choice because of how the formulas were set up, so I'm going to go that way. Now let's look at the next example. Example 5 reads, a recently retired couple needs $12,000 per year to supplement their Social Security income. They have $150,000 to invest. They've decided on 2 investments, bonds yielding 10% simple interest and certificates of deposit yielding 5% also simple interest. How much should be invested in each to yield exactly $12,000 over the course of a year? Hopefully in reading that last line you realize we're asked for the amount of money that we're going to invest in the bonds and the amount we're going to invest in the CD, the certificate of deposit. Let's call B the amount to be invested in bonds, and that's going to be in dollars, the amount invested in bonds, and C the amount invested in the certificate of deposit. And this is a crucial step here in recognizing what it is that we want to look for in the problem. Now let's read back through this. The couple needs $12,000 per year. They have $150,000 to invest. Well, one of those is directly related to B and C, and that's going to be the $150,000. That's the total they have. This is related to the amounts they have for both, or for each. And hopefully you're going to see there, B plus C is got to be that total amount, the $150,000. For the rest of this, what we really want to notice is that we're mixing together those 2 investments. We're putting some of it at 10% and some of it at 5%. And this is really a type of mixture problem. Most mixture problems are going to involve an equation that's kind of like this. It's going to be of the form, let's pick some variables. We have some rate Q times some variable X plus some rate R times some variable Y times some overall rate, well, let's call it S, times the total, X plus Y. And sometimes it's a little hard to see this, but when you have things in different amounts, we've done some problems with mixing coffee beans or mixing nuts and chocolates or raisins. We've done some different problems like that that we're being charged different amounts for. Well, here we're earning interest at different amounts. It's really the same process going on here, and that's what you want to notice. So what we see here is that the bonds are earning 10% simple interest. So let's kind of off to the side. Let's kind of look at what that means. So if you had that you had $1,000 in bonds, let's make it $1,500. You had $1,500 that were in bonds, and it's earning 10% interest for a year. Well, I would take 0.10 times 1,500. That would be $150 or whatever it is. But to get the amount that it would earn over 1 year, I'm going to take the rate times the principal times the time. Here, the time is just 1. Don't need to worry about that too much. But in general, to find the amount the bonds are going to earn, I'm taking 0.1 times B times 1. I'm not going to really write the 1 down here for this 1 year problem. And that's exactly what I want to do over here. So to give me the total amount earned on the bonds, I'm going to take 0.1 times B plus the amount earned on the CDs, 0.05 times C, and that should equal the total amount of interest earned. Now here, this S times X plus Y term, it's just going to be 12,000. We know we're earning 12,000 overall. That's the total interest earned. This is the amount of interest in the bonds. This is the amount of, let me make that a moment clearer. This is the amount of interest earned for the bonds. This is the amount of interest earned for the CDs. This is the total amount of interest. Everything in this equation represents the same type of thing, and that's very important in these problems. Alright. As I look towards solving this, again, my methods are substitution or elimination. And of course I can always do anything that will make my life simpler before I start. So noticing that these involve fractions, I'm going to work, or decimals, I'm going to work to get rid of those before I start. There's a few different ways that you can do this. One that will certainly work would be to multiply both sides by, well, let's say 100. 100 is going to work just fine. You could choose the other things, but 100 is going to work pretty well. So 100 times 0.1b should be 10b. 100 times 0.05c should be 5c. On the right hand side, 100 times 12,000. Well, let's add a couple zeros to that. Should be 1.2 million. Alright. Now, so my first equation is that b plus c equals 150,000. My second equation is that 10b plus 5c equals 1.2 million. I can go a couple different directions with this. Use substitution or elimination. Last problem we used substitution, so let's do elimination with this one. So let's pick red here. I want to multiply the first equation by some amount so that when I add it to this new version of the second equation, I get one of the variables to cancel out. I'm going to pick a negative 10. Multiplying through by a negative 10, I'll get a negative 10b minus 10c equals a negative 150,000. One more zero, one more zero. Alright. And I want to add those two things together. Let's go back to black. The 10b's 10b plus a negative 10b, that's 0. 5c plus a negative 10c should be a negative 5c. And looking at these two terms over there, I should end up with a negative 300,000. Dividing both sides here by a negative 5, I should see that, scroll down here a little bit, I should see that C will work out to be 60,000. Now to solve for B, I'm going to look back at the first equation, which said B plus C equals 150,000. I now know C should be 60,000, so I'm going to plug that in for C. So I'll have B plus 60,000 equals 150,000. Subtracting the 60,000 from both sides, we'll get B equals 90,000. So here, we're going to see that the couple would want to invest 60,000 in the 5% yielding certificates of deposit and 90,000 in the 10% yielding bonds. Now, I want to do one more thing on this particular problem. They told us they can earn 10% on bonds and 5% on CDs. I think most rational people are going to go, well, let's just put all of it in the higher yielding interest one, which seems reasonable. Except we never really know that in the real world. In the real world, we have some goals maybe, like we know how much we want to make each year, It's like 12,000 here. And we know that the higher yielding stuff might be a little more risky. So, well, while we really want to aim for this 12,000, we're only going to put as much in the 10,000 in the 10% yielding as we absolutely have to, because it might be 10% or negative 30% as we've seen lately in the real world. So you want to be a little careful in reading these problems, doing what they ask, but bear in mind there are related problems in the real world that people do that may not seem very sensical but have good reasons behind them. Example 6 reads, with a tailwind, a small airplane can fly 600 miles in 3 hours. Against the same wind, the airplane can fly the same distance in 4 hours. Find the wind speed and the speed of the plane. Assume the wind speed and the plane speed are both constant. Alright, so we need a couple variables here. Let's say, well, let's do the first one that comes in the problem first. We'll say the wind speed is W, speed of the wind. And let's notice what the unit should be, since we're dealing with miles and hours and miles per hour. And the other thing we're dealing with is P, the speed of the plane. The plane in miles per hour as well. Alright, so let's read through that question again. They can fly 600 miles in 3 hours, or same distance. Let's write that as 600 miles in 4 hours. This seems like a distance equals rate times time problem. So that's something I'm going to be bearing in mind in both of these problems. And in fact, it pretty well looks to me like I know 600 is going to equal R times, well, in the first one it's 3, and in the second one, looks like 600 is going to equal something times 4 in those two cases. So let's kind of read through that again and see if we can figure out what those rates are, because it looks to me like these are our two equations. With a tailwind, the small airplane can fly 600 miles in 3 hours. Against the same wind, the airplane can fly 600 miles in 4 hours. It seems to me that the tailwind is making it go faster. The wind is picking it up. And what we're going to see here and what we're going to assume here to be true is that the speed with the wind is just P plus W. And when the wind is going the other direction, we're going to subtract the wind from the plane speed, and that will be P minus W. And that's how we're going to do this problem. But these are generically just distance equals rate times time problems. And each of these will work out to be our linear equations. Alright, so I'm going to move over to the other side of the screen here. So as I do that, I'm going to do one thing. I'm going to distribute the 3 for the first equation and distribute the 4 for the second. So my first equation becomes 600 equals 3p plus 3w, and the second equation becomes 600 equals 4p minus 4w. This question, I don't think it's particularly obvious which one you want to use, substitution or elimination. Last time I did this in class, they chose substitution, so I'm going to go with that here. Looking at these two equations, let's pick the first one, and I'm going to solve that for one of the variables. Let's pick p. So if I want to solve that for p, let's subtract the 3w from both sides. So that'll give me minus 3w, minus 3w. 600 minus 3w equals 3p. Now I still got that 3 on that I want to get rid of with the p, so I'll divide both sides by 3. That's equivalent to writing 600 over 3 minus 3w over 3 equals, on the right hand side I'm left with just p, which I think is 200 minus w equals p. And that's the correct solution for p from this first equation. Let me point out while I'm here, if you had noticed in this first equation right over here, and you're paying attention, you could have just divided both sides by 3, and that work would have been a little easier. You do not need to do that, but if you happen to notice that at the time, hey, if you can make it easier, that's a good thing to do. Alright, so this is my first equation solved for p. I'm going to scroll down and give myself a little more room to work with here. Now looking at my second equation right here, I'm going to substitute p in there and solve for, let's do it in red, solve for w. So I should have 600 equals 4 times p. P we're saying is equivalent to 200 minus w minus 4w. Well, that's pretty nice because now I have only one variable. So 600 should equal, distributing the 4, 800 minus 4w minus 4w. Combine like terms on the right hand side, leaving everything else the same. I'll get 600 equals 800 minus 8w. Subtracting the 800 from both sides, I'll get a negative 200 equals a negative 8w. Dividing both sides by negative 8. I should get something, negative 200 divided by negative 8. That's going to work out to be 25. 25 equals w. I have my pink equation right here. Already solved for p. I'll plug that in. 200 minus 25 should equal p, or 175 equals p. So the wind speed, w, should be 25 miles per hour, and the speed of the plane should be 175 miles per hour. Example 7 reads, a coffee distributor is blending a new coffee that will cost $3.90 per pound. It'll consist of a blend of $3 per pound beans and some $6 per pound beans. What amount of each type of coffee should be mixed to make 10 pounds of blend? Reading through there, I see that I'm looking for the amounts of coffee. Let's call X, let's have the right thing set. Let's call X the amount of one kind of coffee, of the $3 per pound coffee. And Y the amount of $6 per pound coffee. Alright, so those are my variables. Now reading back through this, it looks to me like this is a mixture problem. And we said this a little while ago. Those generically fall into to having some equation like q times x plus r times y equals s times x plus y, the total amount of whatever x and y are. Now here, this is certainly in this vein, and we're seeing the different rates x and y are at. In fact, they're in our definition. And we see the rate overall, and we see something else here. So let's read for this something else. What amount of each type of coffee should be mixed to make 10 pounds of the blend? What that's telling me is the total amount I'm going to use is 10 pounds. Or, well, adding up the parts, the x plus y is going to equal the total overall of 10. Looking at the mixture part of the problem, well, each pound of the x coffee costs $3, so the total cost of that is 3 times x. Each pound of the y coffee is costing $6 per pound, so the total cost of that is 6y. Well, we want the mixture to cost $3.90 per pound. I think that's on the screen. $3.90 per pound. And so we're going to see that as part of our problem here. It's $3.90 times the total. Nicely, hopefully you recognize the total amount of coffee is 10 pounds. So we know that's just 10. Simplifying that second equation, it's going to be 3x plus 6y equals 39. Alright, looking at this, looks like a good problem for substitution. I'm going to solve the first equation for x by subtracting the y from both sides. So I'll get x equals 10 minus y. Plugging that into the second equation, this nicely reformed second equation there for x, I'll get 3 times 10 minus y plus 6y equals 39. Distributing the 3, I'll get 30 minus 3y plus 6y equals 39. Combining like terms on the left-hand side, I'll get 30 plus 3y equals 39. Still working to get this y by itself. I'll subtract the 30 from both sides. Give myself some more room. We should see 3y equals 9. Dividing both sides by 3, we'll get y equals 3. And again, this was the amount. This was the number of pounds of y. Now for x, we saw a little higher. We have x equals 10 minus y, or x equals 10 minus 3, or 7. Again, and the units for both of these are pounds. So we want 7 pounds of the cheap coffee, the X coffee, the $3 per pound coffee, and 3 pounds of the more expensive coffee, the $6 per pound coffee. And that'll give us the mixture that should be for $3.90 per pound. Example 8 reads, a company sells its basic wood stove for $475. Each month, the company must pay $7,500 in rent, overhead, and other fixed costs, regardless of how many stoves are made. The materials and other costs that go into each stove total $175. That is, the variable cost per stove is $175. Throughout this problem, we will assume the number of stoves made is the same as the number sold. Question A says, determine the function that represents the revenue as a function of the number of wood stoves sold, X. Okay, that actually says lots of things here, so let's start here. The number of wood stoves sold is X. That's the last part of that line. We're trying to find a revenue function. So our answer's got to look something like this. R of X equals. Well, now this actually requires some knowledge of what revenue means. And revenue means the amount of money that's being brought in this case. In this case, it's being based on the number of wood stoves sold. So reading carefully back through the problem, we're going to see that the wood stoves sell for $475 each. Let me highlight where I'm at. $475 each. So each one sells for $475. I'm selling X of them. Well, I think the total amount I'm going to bring in based on that should be 475 times the number I'm selling. It's a little bigger than I meant, but that'll work. So the revenue function as a function of X is 475X. Alright. B. Determine a function for the cost as a function of the number of wood stoves sold. Well, I'm going to get an answer that looks like C of X equals something. So reading through here, my costs, well, got to pay $7,500 in rent and overhead, and the materials cost $175 each. They also say this is the same as the variable costs being $175. And what that means is that the $7,500, it's always going to be there. I can't get rid of it. So it's my fixed cost. It just sits around. The variable costs, they depend on how many wood stoves I make. In this case, we're saying we're making X wood stoves. So each extra stove costs another $175 to make. So the variable costs are going to contribute $175 per stove, or 175x to this. So the cost function should be 175x plus 75. Part C asks us to sketch a graph of the two functions. And really the point of this is to have us see how these two functions interact together. So let's look at this. If we look at R of x first, the function, we're going to graph y equals R of x, which is 475x. Well, there the y-intercept is 0, the slope is 475. It's going up pretty quickly. Call that y equals R of x. The other function, c of x, equals 175 plus 7,500. All right, here that has a y-intercept of 7,500. Let's graph y equals that. And a slope of 175. So it's a positive slope, but it's not increasing nearly as fast as R of x. So the function should look something like that. So there we have y equals c of x. And what you're going to need to notice here is that these two functions meet. And this is called the point, the break-even point, the point at which the functions meet. I'll notice this is something to pay attention to. Over here, the cost was more than the revenue. They're losing money over here. This is usually in black, but I'm going to do it in blue. The revenue is more than the cost, and they're actually making a positive profit. All right. Question D. Find the break-even point. That is to determine the point of intersection of the cost and the revenue. Well, there we really just want to set the x and the cost and the revenue equal to each other, because that's where they're equal. So let's look at that. We should have 475x, that's our revenue function, equals 175x plus 7,500. Subtracting the 175x from both sides to get all the variables on one side gives me 300x equals 7,500. Moving this over, we'll see 300x equals 7,500. I want to divide both sides there by 300. That'll give me x equals 25. All right, my y value, well, this was the break-even point, so this is where the revenue and the cost were the same, which is going to tell me I can plug this x into either the revenue function or the cost function. So let's do the revenue function. So R of 25, plugging in x equals 25, should be 475 times 25. Whatever we get from that. So this should be, working this out separately, I see that this should be $11,875. Alright, so we need to sell at least 25 stoves to break even, and the amount that we'll make when we break even is $11.75. That is the revenue we'll bring in, which is the same as the cost at that point. So that's where the profit would be 0. Hope this helps.